Hey there, as we jump into chapter 2, all right, we're up to multi-step equations. So one thing you want to do is kind of remember what's the order of operations, right? We have PEMDAS. What's that stand for? And as we solve equations, okay, so take a second and review what that is, what that means to you for the order of operations, right? Parentheses, exponents, multiplication, division, and then addition, subtraction. Remember, these things go together. They should be left to right when they're both present, and that's all that we have. Okay. As we solve equations, we're always going to use the inverse property. We just talked about that in chapter 1. That means if you had x plus 5 equals 8, you're going to subtract 5. If you had 5x equals 25, right, you're going to divide by 5. Right? These are inverses, dividing by 5 and subtracting 5. Okay, same idea if it were in reverse, x minus 5 equals 8, you would add 5 because plus and minus 5 are inverses, multiplying and dividing by 5 are inverses. Okay, so that's what we're going to jump into. So we'll start with our two-steppers. So the first thing that should be done, needs to be done, must be done, is you have to add 17 right here. Okay, we know at some point we want to divide by 7 to get rid of it, but the order does matter here. So 7x now equals 77. And you thought you were going to need a calculator, didn't you? Right? If x is being multiplied by 7, you're going to divide it right out. So x ends up being 11. There we go. Example 2, as we move to the right, what happened here? This seems really scary. T divided by 5? Well, I don't want to do that first. I have to get rid of the 21 first. Okay, so let's get rid of 21. So t over 5 equals 14 minus 21. Well, that's no good, right? That means if I had $14, but I wanted to buy something that was 21, I would be $7 short. So it's negative. The next thing we have to do is t is being divided by 5, so we have to multiply by that 5. And then we'll finish this thing up, right? Because these 5s will cancel. So t equals negative 35, and we're in pretty good shape. Okay, so in that one, the order mattered because I had to make sure I added and subtract. Okay, I point that out because the number 3 has a little star on it, right? All of this stuff here is being divided by 6. So I have to change the order of doing things. I have to multiply by 6 first, okay, so that I can cancel these out. So I have x plus 13 equals, I have a negative and a positive, so it's going to be negative. All right, so 12 times 6. So 12 times 10 would be 60, and 12 times 2 is 12, so it's 72. And then our last step is to subtract that 13. These are both negative, so it's going to be an even smaller negative number. It'll look larger, but smaller because it's further to the left. So we're at 85. Negative 85 is our final answer there. Okay, so a big difference in 2 and 3, right? Since it's all being divided by 6 versus only t being divided by 5. It dictates the order in which we need to solve these equations, even though they have the same steps, just different orders. All right, number 4, we need to come up with an equation. 2/3 of a number minus 6. Okay, so a number, we're going to use x for that because it's an algebra class. So I need 2/3 of that. 2/3 of a number minus 6 is 10. And then we'll solve it. Why? Because we're algebra ninjas. We're good at this. All right, so I get 2/3 of that number. We're going to get rid of the 6 first. That'll be the first thing. So I get 2/3 of x equals 16. All right, well, normally we would divide by 2/3, right? But we're in high school now, so we're not going to do that, right? We're going to multiply by its reciprocal because that's what truly happens here. And while I'm doing that, to make this part a little bit easier, right, now we get 6 over 6. So these just cancel each other out. So x equals, and now we'll work on this side and say, can I reduce anything? 3 over 2 doesn't reduce. 16 over 1 doesn't reduce. But 16 over 2, that surely does, because 16 divided by 2 is 8. 2 divided by 2 is 1. So now I have 8 times 3 is 24. 1 times 1 is 1. So my answer is just 24. So that means 2/3 of 24 minus 6 will give me 10. So we could actually check it out and see if it works. Pretty good stuff. Okay, so a big key here was using this reciprocal to get rid of it. All right, we're going to show you a couple consecutive integer problems on how to set them up, because again, we're in an algebra class. So this is something that we are tasked to do. So the first number, because I have three consecutives, is x. The second number, consecutive integers. An example would be 1, 2, 3. So that makes this x plus 1, because that's how I get from 1 to 2, I add 1. Now for the third number, how do I get from 1 to 3, is I add 2. Okay, so that's our setup for consecutive integer problems, right? That's always going to happen for consecutive integers. And we want to see this set up algebraically. All right, now we want to take these three, and they're going to have a sum. So that means you need x plus 1 plus x plus 2, and that has to equal negative 96. Okay, so all these parentheses were kind of useless. They're just trying to show the first, second, and third. So what I want to do is go and collect all my like terms. So I have 3x, and I also have 1 and 2, so plus 3 equals negative 96. All right, so you see why this falls where it does. We're solving equations just like we did up above. So the first thing we'll do is subtract 3. So 3x equals negative 99, and then divide by 3. So that means my first number, x, is negative 33. Negative 33. Now, often, I'm going to make sure that you answer this by telling me all three numbers. So if I had negative 33 right here, negative 33 plus 1 is negative 32. And negative 33 plus 2 is now negative 31. Once we get the pattern in which way they go, we don't really need that equation. So does negative 33, negative 32, and negative 31 add up to 96? Yeah, I believe it does. All right, that means we did it right. All right, the next one, we threw an extra vocab word in here, right? 3 consecutive, so I know its first is x. The second, what's that vocab word this time? Odd number. Okay, so basic example, 1, 3, 5. How do we get from 1 to 3? I add 2. Oh, a little bit different, eh? But I do want 3 of them. So for the third one, it's x plus, how do we get from 1 to 5? I add 4. Again, we want the sum. They need to add up to negative 75. So I have 1, 2, 3, 3x. I have 2 and 4 plus 6 equals negative 75. How did I get that? That was from just doing this x plus 2 plus x plus 4 equals negative 75. And once you've seen this a few times, you just kind of go here and add them up. So you get 3x and 6. Right, let's start solving. Minus 6 minus 6, 3x. You're equal to negative 81. I hope that works out, right? Divide by 3, divide by 3. So how many times does 3 go into 8? It's 2 times. Okay, I got left over is a 2, right? Because that would have been 6. So we're looking at negative 27, right? Are those my odd integers? Well, that's only one integer, so I can't be done yet. Negative 27. Negative 27 plus 2 is negative 25, and plus 4 is negative 23. So one key here is I want to make sure that my problem said odd. My answer came out to be an odd. It said integer, which is key, which means it can be negative. So that's a good thing. And I think I skipped over that. It was a negative divided by a positive, so I just wrote negative right away. Okay. All right. And one more time with the vocab. So consecutive integers, this time we're going to deal with evens. So first get you an example, 2, 4, 6, 8, because it said 4 of them. So the first one, like always, is x. Second one, x plus, how do we get from 2 to 4? Plus 2. Oh, so it looks like it's always going to be plus 2 plus 4. This one has a fourth one. Holy cow. How do we get from 2 to 8? Plus 6. All right, so if I add all of these up, I've got x plus x plus x plus x. That's 4x. I've got 6 plus 4 is 10, plus 2 more is 12. This has to equal 60. So what are my even integers? So that has to be an even number when I'm done, just using that vocab to help recall what happens. Let's subtract 12. Okay, so 4x. If I take away 10, I'm at 50 and 2 more, so I'm at 48. Oh, look how nice that is. Divide by 4. X turns out to be 4 divided by 4 is 1. 8 divided by 4 is 2. So my first number is 12. They're consecutive even numbers, so that means the next one, 12 plus 2 is 14. And we see what's going to happen. So it should be 12 plus 4 is 16, and 12 plus 6 gives me 18. So these are my 4 numbers that I need to answer that question. Okay, so it doesn't matter if it's consecutive even or odd. We need to use this x plus 2, x plus 4, because we're starting with an even or an odd. So we want to make sure we stay on an even or an odd. Okay. The very first one, remember, was just regular consecutive integers, and that's where we use plus 1 plus 2 after our setup of the first one is x. Okay. So that's solving our equations. Do you have an exit pass? I do want to see that you jotted this one into your notes. And then if you're good with equations, you'll have about half the class to work on some of these. But if you want to work on them ahead of time, you're more than welcome to do so. Have a great day.